Okay, this is Mr. Keaton here talking today about inductive reasoning, lesson 2.1. We have 3 vocabulary words that are very important for this section. The first one is conjecture, which is an unproven statement based on examples, observations, or patterns. The second one is inductive reasoning, which is the process of noticing a pattern and making a conjecture or coming to some kind of conclusion. And then we have a counterexample, which is finding one specific case which proves a conjecture to be false. So let's go ahead and look at a few examples of that. The first one we have here, we have 1 shaded region. In the first figure, we have 2 in the second figure, and 4 in the third figure. What are we going to have in the fourth figure? That is the question here. So to do that, we could draw it, and you guys are going, oh, Mr. Keaton, come on. And you're right. We can see pretty straightforward that we're going to have 8 shaded regions. It keeps doubling each time, doesn't it? So there'd be 8 of these shaded regions. So we get 8 shaded regions. And we're simply noticing that from the pattern. And if we're noticing it from a pattern, that is called a inductive reasoning. That's correct. Moving on. Next one, we see another pattern here. It goes 1,000, 500, 250, 125, and you're quickly going. The first time it's 1,000. The second one is, the second figure is 500. The third is 250. The fourth is 1.5. What is the fifth going to be? We're going to keep cutting them in half, aren't we? So that'll be 62.5. What is the sixth figure going to be? Cut that in half again will give us 31.25. And they wanted 3 of them, didn't they? 3 numbers, so we'll do one more. The seventh figure, we're going to cut 31. So half of 31 is 16.5. And then half of a quarter is 12.5, or 0.125. So we get 16.125 and a half, so 0.625. Correct me if I'm wrong on that. Anyways, moving on to the next example, we were able to find the next 3 figures there. Down here, it asks us to find the number of segments and make a conjecture about what's going to happen here. So we have this first one, we have 1, 2, and 3 segments. The next one, we had those same original 3, and then they added 2 more, so 5. And here we have those same original 5, and they added 2 more, which gave us 7 shapes. So it looks like they're in the fourth, when we have 4 triangles, they're going to add 2 more, aren't they? And that'll give us 9. And then with 5 triangles, they're going to add 2 more again, which will give us 11. So they're repeatedly adding 2 more triangles. So we're making a conjecture about the number of segments. It'll be the figure number plus, oh, is that right? Conjecture about the number of segments in a similar diagram with 5 triangles. We're just adding 2 more each time. Going on to the next example, it says make and test a conjecture about the product of any 2 odd numbers. So we're going to multiply 2 odd numbers. So if I did 3 times 5, I'm going to get 15. So I'm going to make a conjecture that all products of odd numbers are going to be odd. And I'm going to test it by testing some more odd numbers. 7 times 11, 77. What I'm looking is for a counterexample, one that does not work. 1 happens to be one of those numbers to test. It does odd things. And we still get an odd number. So I'm going to make the conjecture that 2 odd numbers multiplied together will be odd. And I can't find a counterexample to prove it false, so moving on to the next one. And here, a conjecture about supplementary angles. Supplementary angles, there's supplementary angles. 30 degrees. Angles are always adjacent. Adjacent means next to. Well, those are next to each other, so that looks good. That's a conjecture. Oh, but supplementary angles don't have to be connected, do they? So, a counterexample proves this statement false. This conjecture up here. So we're going to get rid of it.